Okay, hi guys. So today we're gonna be today I'm gonna try to explain to you guys or like go through you guys this difficult question from 2018 paper 1 question 10. It's a lengthy question and it's really on applications of your differential equations in real life. Yep. So this is a very it was pretty infamous for being a bit out of some people's leagues and also in favor of like H2 or maybe even H3 physics students where they have like inductance and capacitance in their syllabus, so they are already comfortable with these, like some of these terms where I is the rate of flow of charge and the concept of all these concepts, you know. But really you don't need any of this. So first what I would do is I would write down all the constant or like all the letters that I know, because this is a whole mess of letters and I get that it can be kind of scary to see that. So first, in the order that I'm reading, you know, your V, which is the voltage, is in volts, and you know R is in ohms. This is all for just basic use in the question later, so that you're not so confused and that you're familiarizing yourself with the terms, so it's like not so foreign anymore. Okay, and then your T is in seconds, and your Q is in coulombs, your amount of charge, coulombs. Okay, and it's also given that RCL are constants and an initial condition. So you know RCL are constants, so in any integration or differentiation they shouldn't be regarded as variables and stuff like that. And you also know when T equals 0, I equals 0. So you know these two information. So the first part is actually pretty easy. You're given this differential equation, so I'll write it down over here. So you have L di over dt plus Ri plus your coulomb over charge equals volts. So that is your differential equation. But another important information which you have to use in the first part is where I equals the rate of flow of charge. So knowing this, we can integrate with that's a pretty big mistake. So knowing this, we can differentiate, been doing a lot of integration practice with respect to, you have to state this because you will never know. It shouldn't be implied. So you know L is a constant to the left, and I differentiate this again with respect to T, you get the second order derivative. Then R is a constant and only I is the variable, so when you differentiate that with respect to T, you get the I over dt. And then you know 1 over C, or you know C is a constant, but in this case it's 1 over C, that's the constant. And you know your Q is not a constant, it wasn't stated anywhere, so you should treat that as a variable and differentiate that with respect to T. So since anywhere in the question you can't see any dv dt terms, you know. If there were dv dt terms, you know, V is a variable, so they asked under certain conditions on V, which should be stated, where V is a constant, because constants, when you differentiate constants, it will go to 0. So this is your condition. So this should be hashed so people can see. So since given in the question that I equals the rate of flow of charge, you know that L, you basically have to just copy everything here. So 1 over C is 1 over C times dq over dt is basically 1 over C times I. So that is equals to I over your coulombs, your capacitance, equals to 0. And that has been shown. So that's an easy little 2-marker. Okay. So now where it gets very tedious, you know, it's 5 marks, probably going to involve integrating and stuff. So, okay, it's now given that differential equation part I holds for the rest of the question, okay? Given that I is given this gigantic mess, given that I equals to AT e negative RT over 2L is a solution of the differential equation where A is a positive constant, show that C equals to 4L or R squared. So, given this information, we are able to carry out some of the works. Hold on. Okay. So given all this information, we can now carry on with part 2. So you know your current is AT E negative R over 2L times T. Okay? So you can what you want to do is you want to find C, where C is a constant. So you should be using your original equation. You should try and get all these individual terms right into your equation. And then once you do, because you know that 4L and over R squared, since L and R are constants, you're trying to show that something is constant. You have to find a constant, you know. Okay, so I'll start by differentiating this with respect to T, because you want your di dt term. So differentiating this pretty simple. Treat A as a constant, T, so you have to do product rule, right? So differentiate T and you leave the rest. So you have A E negative R over 2LT plus, then you differentiate whatever this is over here. That is negative R over 2L times your AT E negative R over 2LT. Okay, so that is pretty complicated, but not that bad. You can further simplify actually. You find that A E to the power of whatever this is common between these two terms, so you can factorize that out actually pretty easily. So that's going to just be 1 minus R over 2LT. Okay, you got that now. And then okay, yeah, that's all you gotta do, I think. Or actually, you can actually make it even simpler by removing the denominator. So you can remove the denominator by A over 2L, because it's a constant. A over 2L, E negative R over 2L, T. When you divide 1 by 1 over 2L, you times it by 2L. So you get 2L minus RT. Yeah, even simpler, I think. Okay, can. So this is your DI/dt term. So you can, again, differentiate both sides. Differentiate with respect to T again. You don't have to write it again, but you know, polite. Okay, so given that, you can know that the second order derivative of di dt squared is equal to, so here you have to do product rule again. And it's pretty tedious, yeah. So firstly, we know A over 2L is a constant, so you can just take that out of everything to make it even simpler. Then you differentiate one term and then keep the other. So you keep this term and you differentiate this whole thing. Since L is a constant, R is a constant, you just have like R. Okay, and then when you differentiate this term again, you get negative R over 2L and then E negative R over 2L T times 2L minus RT. Pretty process is not so complicated, but it does look complicated from a like further view, you know. It's okay because A levels is just about how you push through. It's just all they want their students to do is just push through, or else we would be cooked, you know. So then like that, we would know that okay, like this. What do we do now? We can expand it into here. So we got negative AR over 4L squared times this. I think it's better to expand this. So then you have, it's a lot of writing though. This question is all tedious. It's like it's just very tedious. That's the problem with this question. So you got AR divided by, this is 2L as well. E negative R over 2LT, and then you times RT. That just becomes positive AR squared over 4L squared T E negative R over 2LT. Alright, I think that is pretty simplified. Everything has been expanded out. So this is just prepping for you to sub into this disgusting equation. So subbing, so actually what I would do personally, so therefore this is your di dt term, this is expression 1. Therefore, d squared I over dt squared, and this is expression 2. So you can use it to like further like clean up your answers. So subbing in 1 and 2 into your differential equation, you have L. Oh damn, that's freaking huge, but we persevere. But personally, if I was doing this paper, I would be crying, not gonna lie, because this is question 10 of paper 1, and it's so brutal. It's like after, I think, I haven't seen the 2018 paper, but I think it wasn't that easy. Like I remember it not being that easy. And then your IDT term, there's a lot of reference. Probably 3 pages was given to do this question because it's so long. The workings are so long. So you have E minus 2LT 2LRT, boom. Okay. Plus I over C. Okay, done. Oh my goodness. Okay, it's been subbed in. So then, oh, my neck hurts. So then, what we have here is just process of like simplification. Actually, wait, hold up. You don't want items, or you don't want any more variables, so you can sub this your original equation given in the question in your equation, you know. Okay. So once we've been given these equation, all right. Okay, I take some time because this is diabolical. I think this is simplified. This is the same term. So then, okay. So this is the same as negative AR over L times E negative R to LT. So yeah. I could have simplified it a little bit more in the previous step, but you know, it is what it is. So you continue. So since you're multiplying L inside, so you know you just have AR E negative R to LT. So you're remaining this, it's just AR squared for L instead of L squared, because you are multiplying L into it, and here you multiply R into it. This T times 2LRT plus AER 2LT over T. Okay, personally, when I reach this point in the question, I would be banging my head on the table. Like, honestly, I wouldn't think I'm correct. There's so many points in the question where you can make a careless mistake. It's just very, very, very mentally laboring. This question is a test. It's truly a test, man. Like, okay. So since you have all this, you can, I think you can expand this out. Oh, I feel like maybe we should try to be more efficient. We should, like, while we are writing, think of the next step. Because I do not want to continue rewriting all this, like, over and over again, man. Like, it's so tiring. Like, I'm not even in a freaking exam anymore. Like, I'm not even in the exam hall doing this. I think I wouldn't be surprised if, like, maybe 2 hours and 30 minutes into the paper, I hear people crying because what am I looking at? So then this term and this term you can see are common. So these two terms cancel out, and then these two aren't common. Okay, so then we have AR squared for L. I think you can bring out the T, not gonna lie. It'll look nicer. So, like, as in bring it out to the end. So you have AR squared. Like, you can definitely maybe accidentally put an AR there instead of AR squared, like in one of the steps, and just it will ruin the rest of the question for you. Like, you imagine having to do all this. You do one step wrong somewhere and didn't know, and you have to go back and fix and then revisit, change all the steps along the way you did. Please be careful, guys. Like, when doing all these tedious ass questions, please be careful so as to not go through that trouble. Okay, so we have this. We want C. So I think we can. What's common here? Okay, we can see that A E negative 2R over 2LT are common among all terms. So A, yeah, they don't have an R here or R squared. So I think you can just have R squared over 4LT R squared 2LT 1 over C. Okay. Oh, see, look, make the freaking careless mistake. We are given a T E to the power E. And I've been copying without T. Oh my goodness, massive careless mistake. This is bad presentation, but God knows gracious, bro, I wouldn't have known none of this. No, doing question. Okay, so this is your T instead. Okay, so then you can remove the T. Okay, since this is T0, it's a valid solution. So this one you times 2 on bottom and top. This becomes 4, so it's negative R squared over 4L plus 1 over C, 0. Yep, I can see the answer. That's for 4L. Hence, holy damn, we made it. C, since you reciprocate both sides, 4L over R squared. So is that the expression we need? 4L over R squared, yep. Oh my god. So this is your 5 marker on your probably last, or I think it's the second last or last question. Not too sure, but yeah. So that's absolutely diabolical. But we carry on. We have 2 more parts to the question, and they're not low marks in it anyways. Okay. In a particular circuit, R equals 4, L equals 3, and C equals 0.5. So since I don't want to keep referring back, I'll rewrite that. So R equals to 4, L equals to 3, C equals 0.5. Okay. So what do they want? Find the maximum value of I in terms of A, showing that this value is a maximum. Okay. So we have this equation, the gradient equation of I, to use to find the turning point. So you know your di dt. Oh my goodness. Okay. So A over 2L, E negative R over 2LT. Oh, my sweat in my freaking iPad. 2L E negative R over 2LT times 2L minus RD. Okay, you have this, right? Okay. Alright, so actually, I don't think this will lead you anywhere. Not for now. So what equations shall we use? Really, RL, oh, these are constants, right? Oh, we can use this, yes. Okay. So subbing into your DE. This is a 25-minute long question, man, please. Subbing into your DE, you have 3D squared I over dt squared plus 4 di over dt I over ci over 0.75 equals 0. Okay, so also you know that di over dt equals to L is 0.75. So yeah, actually we are using that. That's good. We know that A t E negative 2/3 t, because after we sub in everything, negative 2/3 of t. Okay, so this you can simplify out your A E negative 2/3 t to get 1 minus 2/3 t. Okay, there we go. So at your maximum points, there's only one you don't know. So di over dt is 0. So A E negative 2/3, I'm going in 1 minus 2/3 t, 0. Since A E negative 2/3 t is always greater than 0, as it's an exponential function, 1 minus 2/3 c equals 0. 3 is 3 over 2. Right? Yeah, 3 over 2. Yes, okay, therefore t is 3 over 2. So hence, your item, so what is the question asking again? Okay, I, maximum value of I. So you know your t. So you know your A, your I as well. So you have, sub everything in. You have 3A over 2 E negative 2/3 times 3 over 2's. This simplifies 3A over 2 E negative 1. Therefore, your I equals 3A to E. Oh wow, nice, pretty clean. So that's your I value where it's maximum. Okay, so you can find, to prove that it's maximum, use your d squared, your second derivative test. So you want to subbing I equals 3a 2e di dt is 0. You have 3 d squared I dt squared plus 0 plus 3a 2e 0.75 equals 0. So then this will simplify d, therefore d squared I dt squared is negative 2a, right, over 3e, which is less than 0. Hence, at I equals 3a to e, it is maximum. Okay, there we go. Okay, so last but finally least is part IV of the question. You want to sketch the graph. Okay, it's not that bad. We can probably just plop that equation. So you just want to sketch. So you want to plot the equation. Okay, then I think the equation was something like doesn't touch y, it doesn't touch the x-axis. It starts from 0, so it's like this, I think, right? So this is your d, this is your I, and then you know what is maximum point 2, no, sorry, 3, wait, hold on. No, is that 2L over R over 2AL over RE? Boom! This is our sketch. Thank you so much for watching.